Question 12, part 1, that's just straight out comparing to a template. You have to complete the square twice in order to make it look more like the template than it currently does. But when it does look like the template, it'll be really clear what the centre and radius are. The template, by the way, is this thing. Roman numeral part 2 is just simultaneous equations by gift. You're given y equals x plus 2. Substitute that into the equation of the circle and you're away. And for Roman numeral part 3, not quite sure what I'm going to do for that. I will draw a diagram later on. Okay, so here's Roman numeral part 1. I'm going to complete the square twice on this. First I'm going to get the x business with the x business and the y business with the y business. Put the number business on the other side. Completing the square is all about hating what's in third position. Currently there's nothing in third position. I hate that. So I'm going to create some spaces to put something in there. What would I like to be in there? Halve this, then square it. So I'd like there to be a 1 there. Halve this, then square it. So I'd like there to be a 4 there. Here they come. I'm adding 5 to that side, so I better add 5 to that side. Now factorise. And now compared to the template, so a equals 1, b equals 2, r equals 5. So the centre is 1, 2, and the radius is 5. Now, circles are really easy to graph. So 1, 2 is there. Whoops. Graph that again. 1, 2 is there. Go up 5. 3, 4, 6, 7. Go along 5. Down 3. That's your graph. Okay, now, that's just preparation for part 3, by the way. He didn't actually ask me to graph it, I'm just getting my story straight. Y equals x plus 2. Now I'm just going to graph y equals x plus 2, which is really simple. It's just the y equals x line lifted up by 2. So it's going to hit twice, so if this method doesn't give me 2 answers, then I've made a mistake. Here comes the method. This is me rewriting that, but y has become x plus 2 because I'm told that that's what it is. Let's just take those as sensible, so that's 4, 6 I'm claiming. And that's negative 1, negative 3, negative 1. I just expanded that, collected like terms, halved everything, factorised, and then out popped the answers. I just wondered how to make each of these factors equal to 0, and that's what I got here. So the coordinates are as I've written there, and find the angle ACB. So C is the centre, A is that, and B is this. So I need this angle here. Well, what I think I'm going to do is use the cosine rule on this triangle. To find this angle. Now this distance here is 6 minus -1 squared plus 4 minus -3 squared. That's the distance formula on that. This distance here is 1 minus -3 all squared plus 2 minus -1 all squared. And this distance here is 4 minus 1 all squared plus 6 minus 2 all squared, added together with the square root. So I'm going to call that capital A, little b, capital C, little c. Now, I'm just suspecting that using the cosine rule might be overkill here, especially since I've used the cosine rule already in this examination. I'm just going to simplify these to see if there's anything special about this triangle. That's square root of 98. That's 9 plus 16, square root of 25. Oh, this is an isosceles triangle. So, I think Secretary will be the fastest on this. So I'm not going to use the cosine rule. That's square root of 98 over 2. That's square root of 25. And I want to find this so that I can double it. So sine of x equals root 98 over 2 over root 25. Do shift sign on that. Shift sign root 98 over 2. So x equals 81.8, etc. So therefore 2x, so angle A CB equals 2x equals 163.7. But as I say, using the cosine rule on that would have been fine as well.